Good afternoon, everyone. We will get started in a minute or so. I'll just let people join. Okay, I will kick things off as people are joining us today. So welcome everyone to our Friday Lunch and Learn. Today we will be talking about low carbon concrete and specifically calcined clay and how that is supporting us in our decarbonisation journey at Vida. So my name is Polly Goulet-Phillip. I am the Senior Manager in the Ecologiq team. I've got Lauren in the background helping with IT. Next slide, thank you. So I'll just start off with an acknowledgement of traditional owners. So today, acknowledging the traditional owners on the land of which we're meeting. For me, that's the Wurundjeri people. Paying my respects to their elders past and present and the elders of any other Aboriginal communities who may be here with us today. I always like to talk about the seasons, which pretty cold and grey day today in Melbourne, in Naarm. And that's very much the warring season, which is the season of the wombat. Good weather for a wombat with a furry coat. And we're very soon approaching the Gulung season, which is the season of the orchids and the wattles coming out into flower, which I actually noticed a few mornings ago walking the dog. So lovely to see some colours and smells starting to appear and sort of take us out of the winter months. Next slide, thank you. So just a really quick intro into Ecologiq for anyone who doesn't know what we do. So we are an initiative of the Victorian government. We recently or semi-recently moved into Vida services. So we work across all of Vida and also Suburban Rail Loop Authority. And our remit is really around the recycled first policy, so optimising the use of recycled and reused materials across transport infrastructure. So the policy itself is fairly simple. There are sort of two asks. One is really around optimising the use. The word optimise very intentionally used because there are no hard and fast targets, and we really just want to see improvements on the use of moving away from using virgin materials wherever possible. And the second part of the policy is reporting on the materials and volumes used. So I would argue as an engineer the sort of most important part, because that's really the data and what we have to track our performance to date, which as we move on to the next slide, thanks Lauren, you can see some really fantastic outcomes. The policy's been in play for 6 years now, and that's equated to almost 7.5 million tonnes of recycled materials used across transport infrastructure. So yeah, great to see. Okay, so getting to the sort of interesting part of today's discussion, I'm going to be joined by Estella Garces from GHD and Miles Dacre from ACOM, who are also our technical advisors in Vida Rail, and they will be presenting on calcined clay uptake and some examples across Vida Rail and some of our other project officers. And then we will have plenty of time at the end for a discussion, Q&A, so please use the Q&A function down the bottom of your screen. We do have 45 minutes scheduled, but happy to stay on a little bit longer if we have plenty of interesting questions coming through. So without further ado, I will turn my camera off and pass over to Miles and Estella.
Thank you, Polly. Thanks, Estella. Welcome all. Good afternoon, and thank you for joining us. Yes, so we're looking at the progress towards decarbonisation, and next slide, please, Estella. And this one, even though we're obviously looking at the reduction of GP cement, this is primarily focused on calcined clay. And I guess we should be, I think everyone, and I suspect there, unfortunately, a lot of the people on the call are already interested and involved in this, but if you're not, I think key message to get across at this stage is calcined clay is now available in a commercial volume, both a source in Victoria and in Queensland. And that shouldn't be underestimated. That's the first new SEM we've had for several decades. And we want to just bring through some of the early findings that we've got around that, and why it's actually going to be, should be considered a key breakthrough is probably overstating it, but a key weapon for decarbonisation. As you can see, Vida has got these quite tough overall decarbonisation targets. And when looking at the types of projects that we help deliver, it was identified early that there are not too many levers that Vida can pull to get to these. So, and concrete was identified as the key one to do for the next. We've started off in 2023 for the next 5, 6, 7 years to get to these target levels for projects in the next from here to about 2028, and thereafter we'd have to start looking at some other materials and decarbonisation aspects of projects, equipment, and sources of electricity and so on, power. So that's the reason why we've got a short-term focus on getting concrete as low in carbon as possible, and that simply means getting the GP cement content as low as possible, as quickly as possible. And so that's been the focus. But that's, as we all know, working in an industry that's A, conservative with risk, B, conservative in cost, and C, conservative on program. There's a lot of moving parts that need to get right. So within the Vida Rail engineering area, they've working with the sustainability team have identified what are the actions that we need to do as a client organisation with some influence on industry to help industry, all parts of it, whether it's the constructors who have to get new mixes approved, the suppliers who have mixes and need to get them into the system, and also what standards or specifications are getting in the way. So we've identified those, and that's a process of just keeping working on all those three streams to move the dial in the right direction, so we can get an aim. The key aim is to get all concrete used on the projects, preferably. At the short term, we want to get beyond 50% GP replacement. But our actual goal within 2 years is to get everything above the 75% GP replacement, which is a big ask. So everyone involved on this call is part of the solution. So next one, please, Estelle. So we've gone into detail about how we're moving and what we're doing in different areas, and what can be done. And the great thing is that technically we know, we're very confident that technically the solutions are out there with the existing materials up to a point. One of the main areas of concern is obviously in precast and obviously doing work under occupations where high early strengths are a problem. Some of that is already being solved by the concrete companies by transferring the use of our activators and other admixtures that were developed in some cases in response for geopolymers, but coming in. So we actually have got some mixes around that are 75% GP reduction already, with activators involved across the spectrum. So we know we can do it. The other problem, though, is with is getting that very high early strength that is required by precasters, and also the workability and the quality of finish. So that's the tipping point we're in now, is getting those things right. So it's not a question of the mixes not being able to achieve what they need to do as such in terms of structural capacity and, importantly, durability. But it is that workability and replicating the quality of finishes that we're all used to and need. So next slide, please. So this is what we've been doing over the last few years, and the low carbon concrete testing program, and a lot of people on the call will have been involved in some of these tests and trials that have been undertaken on projects, which has been great, because doing these trials on projects means we're having to put the things through the batch plants rather than keeping them in the laboratories, get them out on site, expose workers laying concrete to these materials, and understanding what doesn't work and what does, and then fine-tuning it as we go. I'll hand over to Estella now, but in terms of where we're at, the key point is now is getting the approval for these mixes at a structural level for the high risk. At the moment, everyone's quite comfortable of doing these trials on low risk elements, but what we need to now move is do this fast is to move to prove that these things can be used for the higher risk pre-stress structural elements that are on a lot of projects, other major elements, and we need to solve those. So thank you for that. And Estella, over to you.
Thanks, Miles. So as Maya said, a big part of this low carbon concrete that we are doing with Vida Rail is this structural testing plan that's going to allow us to move as fast as possible to this higher risk or more challenging, let's say, applications with tight occupational time frames and the pre-stressed elements. So I think as a program of works, it's about getting those low-risk applications, creating the demand for this product, while we speed as much as we can to get the evidence to transition this. And as Maya said, all the evidence is showing that it's possible. It's just addressing those workability or finish early age strength. And I'm going to share why we believe and we get so excited about clay, and why we believe clay is part of this solution. So this is just a snapshot of all the trials that have been, not all, but some of the trials that have been, we start back into 2024. Lots of great people, some I believe are in this call today, that did a lot of hard work to get this going, and working with supply chain, identifying sources of clay, getting the clays calcined and so on. And from that early first trial here in Victoria to what we see the industry, where the industry is now here in not only in Victoria but in the country, is starting from those trials and now having over 1,000 cubic meters of concrete laid in projects, SRLA projects and Vida projects. It's just amazing. So what gets us very excited from early stages, I believe, is that even those initial trials and with clays that we can say maybe were not the best reactive clays, all the evidence was quite positive on the performance of this material. And putting that together with all the evidence coming from research, there is over 20 years of research on clays in Australia that give us that confidence that durability and all the other performance is going to be there. So, so as I said, over 1,000 cubic meters of concrete clay, concrete with calcined clay have been poured, and this is because nowadays we have access to these two suppliers of this high reactive clay, and we are seeing more and more of this low risk and permanent applications now in major projects. But what gets us really excited, I think, is what we see in these side trials that we are kind of getting involved and seeing other people doing. Some of the recent ones that Miles and I have been involved is this shotcrete trial. We all know that shotcrete is a very difficult, hard to crack application, and we have been seen this application up to 50% cement replacement with calcined clay and GL cement, actually. And the shotcrete was no issues, was very happy with the outcome of this, and it was the first trial. Everything already went spot on. And what's happening with precast as well, we did a bit of work with SVC and Holcim and got some 20% calcined clay. They do have 40% slag mixes that they supply in their product range, but we got excited with that initial kind of ramp up of strength at 24 hours by replacing 20% of that slag with 20% of clay using standard curing. Further to that, Holcim started doing some heat curing tests, and again, after 17 hours, we can see here that we have, using heat curing of 50 Celsius, we have that 19.5 MPa that give us that kind of evidence that the early strength, that it's critical for both pre-stressed and tight occupations, that can be solved. So of course there is more that has to be done for us to crack those most challenging applications, I would say. Keep working on workability, work with the mixture suppliers, getting trials done to see how the finishing goes. But where we see things going is, yes, that it's possible to get those mixes with 75 to 80% SEM mixes that we already have in the market with other SEMs, but we believe it's quite possible to go further with the calcined clay. And in terms of applications, what we see for our program is we already know that board piles, it's probably we can get those high SEMs. That is, CFA piles for us is a critical element as well that we are trying to crack, and we believe calcined clay is going to be part of solution. Going for that in situ large elements with tight occupations, as I said, understanding the difference between curing and without curing, because might be that we can even optimize what the curing processes that we understand as needed. Maybe there is optimizations that can come from there as well. And the precast, getting how fast as we can to those large elements, pre-stressed elements that are critical for Vida Rail to get to the decarbonization targets that we have. And just to finish, is just like that collaboration piece that all this, I think this fast track that we have seen with calcined clay is because of the collaboration that is happening there, and the importance of having engineering, sustainability, all as part of this part of this change, getting our designers on board of what these materials can bring us opportunity and what needs to be addressed in the design when we are using these new materials. And I will just bring the universities in the collaboration with academia. I know that many projects are already doing this, but yes, get these people, the people that understand about the material and can solve the issues with workability, improve mix design involved, because that is a critical pathway. So for us to get this technology approved as soon as possible and widely used on projects. Anything to add, Myers?
Yeah, might go back to the previous slide, Estella, and just want to focus in on why we believe the approach is we think we could push calcined clay percentages up higher and redesign some fairly novel mixes around it. But the thinking is, if we're going to get the maximum GP reduction in the shortest possible time, is to focus on this idea of we've got approved and proven mixes of 75% slag and combination of slag and fly ash. The clay takes will replace fly ash. So we're thinking, our thinking around this is all those applications would suit the concrete type mixes on the left hand side. So 75% SEM, up to 30, possibly 40% certainly for the shotcrete. So we're sort of trying to get into a range of mixes which are quite confined, but can be used on all those elements, so that we can, if we do the different trials on those elements, then we can cross-reference the data and compile it more quickly. Some of the other things that the clay, and why we're keen on it, is its ability to hold or have retain water, which makes it difficult for doing SUPs and decks, but it does make it more suitable for things like shotcrete, where they don't like bleed, but also self-compacting mixes or very high workable mixes. So again, those sorts of mixes are primarily our focus, because we know they're needed for large in situ elements where you've got high density of rebar, and you want to be able to go to pretty much a self-compacting mix. And Estella's done previous work that she's done as part of her research, is that self-compacting, well-designed self-compacting mixes actually have better durability outcomes than lower slump mixes that get vibrated. So there's a lot of positives in going this way and getting the industry to move more towards these types of mixes. And we believe that calcined clay might make self-compacting mixes more robust, for want of better word, because that's been the previous issue when self-compacting mixes first came into the market in Australia, because of their sensitivity. DOTs and major projects were a bit concerned about the quality control and the ability for segregation to occur. So there's some real benefits that these top-line calcined clays are bringing in that we've got to unlock very quickly, but should be able to solve what we think are the main issues preventing decarbonisation of concrete across the board, which is really exciting. And we don't have the concern on the durability at all, because we've been using these high SEM mixes for very aggressive environments where we want to pretty much, we like to say it, pretty much anything where normal GP cement can't handle, we have to resort to SEM. That goes with high heat reduction, thermal control, shrinkage even, acidic soils, aggressive sulfate, so on. So we're not seeing durability, which is the hardest thing to prove given the 100-year design life. We don't see that really as a risk at all by moving towards these materials, and particularly the introduction of calcined clay. So we're very excited, and would like to get that across, and look forward to working with everyone on this call in progressing this.
Thanks, Miles and Estella. That was fantastic, and I think really the speed of which this has come into application is, noting, Miles, we're talking about an industry that's pretty slow moving. It's very exciting. There's a lot of people on the call today who were involved in the very early discussions 2 or 3 years ago.
And then anyone who wasn't at that stage, we were thinking it'd be 10 years before we'd get a calcined clay. So it's remarkable how quickly it's happened. So really,
absolutely.
A real hats off to the industry, particularly in Victoria, but elsewhere, to make it happen.
And what I've found even more exciting is, people we've spoken to a couple of years ago who thought calcined clay really didn't have a place to play have now changed their tune, which I find really exciting in this industry to see. So, okay, I've got a few questions I wanted to get you both to answer, and then we will open it up to the people who've joined us. But I guess just sort of noting, Miles, you started talking at the beginning around the reduction targets. and we are fast approaching 2027, where the target ratchets up to 35% against a 2005 baseline. What do we sort of need to be seeing across our projects, do you think, to reach that 35% target?
Yeah, that's a big question, isn't it? And no, look, I think one thing I'd like to, I think looking at what we're not doing already, and which we should be doing, is using very low GP cements for pretty much anything other than the high risk. So that needs, we have a bit of a default setting even in the design side of things, that as long as it's a Vic Roads approved mix, that don't want to get involved, that's the default. And I would like to think designers more readily looking at, if I'm designing a 32 MPa element that only has a compressive strength requirement primarily, maybe some shrinkage, that the data is already out there to show that these very high SEM, very low GP mixes will meet those requirements, and like to see people then pushing for pre-approval for these mixes rather than leaving it during the project to just go for a default, because that makes it really hard for the concrete suppliers, because they have these approved mixes, but to get something up and running in a couple of weeks is just not possible. So that's the first call out, is when you're doing your reference designs, is to get up to speed with what's available, not necessarily look for the traditional mixes that you've used in the past, and start thinking, where can I get rid of GP across my mix design or my structural elements as a starting point, and then also look for be proactive in the idea of, okay, if I've got a retaining wall or another element that is quite going to have quite a bit of higher risk, then what are the properties that I need to prove from the concrete mixes, these newer concrete mixes with and without calcined clay, and to again engage with the industry and try and get mixes approved before you knuckle down in your project. So that's a sort of thinking we're going with the Vita Rail alliances, is to be proactive, not wait for trying to do trials under projects that are not pre-planned and not pre-proven. As Stella indicated, one of the things we're really keen about is the high early strength at temperature, and it's not just a question of heat curing, because obviously very large members generate their own heat. So we would like to see people getting the trials out there of large members doing actually temperature match curing, in situ monitoring of strength, and doing it that way, because we see some really, as you see, you get a 4 times strength gain in situ rather than just doing standard cylinders. So that's really the thing we want to focus on.
Miles, anything, Estella, you wanted to add?
I was going to add, in the delivery, I think there is lots that comes back to us, that it's, when there is an issue, that it's like, because it was a low carbon concrete mix. And I think as an industry, we need to get better, because there is lots of issue with any concrete. Anyone delivering projects know that any normal concrete. And as a matter of fact, most of the durability issues that come, as Miles said before, they come from the fact that we use too much GP cement in mixes. So it's about, I think, also getting that we need to be proactive. We know that these mixes might have some work, be different when you are placing. So it's about getting, people on board and understanding that concrete is evolving. And my experience says that when you have these upfront, conversations with people, actually the challenges with low carbon concrete are not at all, easy to overcome. So it's a bit of putting that mindset that, mixes are to be low carbon concrete, and if there is any technical challenge, we need to address as a industry together.
Thanks, Estella. And I guess that kind of brings me on to my next question, which is really kind of around the site feedback and workability. Noting, this is early days, so there's going to be issues, of course. But I'm keen to sort of understand, what have we learned along the way? What are the typical, I guess, challenges? Miles, you touched on shared user paths before, but yeah, what are we hearing from site around workability?
Yep, I think Okay, the main problem is because it doesn't bleed, it doesn't, it holds water. When you're doing decks or paths and so on, you don't get that sort of slickness coming up to the surface, which the finishers really love. It tends to be a bit no different to high slag mixes. They do tend to be a bit sticky, but there's a lot of improvement in the admixtures, and therefore the concrete suppliers, the admixture suppliers, and the concrete technologists involved are solving those problems. And as Estella indicated, really what you don't want to be doing is thinking, oh, I'll grab this, it's been trialed somewhere else, we'll just order it and bring it in, without involving some key people, as Estella said, on site at the batch plant. One of the things with clay, only a few suppliers have it in silos, so it still tends to be added in bags, and that's problematic because if you don't add it in the right sequence, you're going to get problems with dispersion of the clay, and therefore throughout the mix, and therefore those things have caused problems on certain pours. To the extent, we've done some trials, and you'll have, I know Will Gates at Deakin, but I know also Raquel San Nicolas will be standing at the batch plant, looking in the back, making sure, seeing how the mixing is going in real time with the admixture supplier. So we're at that critical stage of taking it out of the pure research into the commercialization, and it needs that level of scrutiny and technical involvement to get it right more often than not. It will still get it wrong every now and again, but that happens with normal concrete mixes. So we don't get it right every time even then. So it's more a question of saying, have I got the right people involved? Have I got the best technical specialist from the supplier on site with me? So when that comes out of the truck, he can look at it and go, no, I need to tweak it, and go and call straight back to the batch plant and say, just adjust this, this, and this. That sort of level of care and needs to be taken. And the good thing is people are willing to do that. That's part of the role that Estella and I have at Beta Rail, is to try and coordinate that sort of involvement on the trials and make sure we don't have consequences that could be avoided, and don't let that happen. So, but Polly, I know you got some more questions, but I kind of hop in with Jonathan. He's got a very good
happy to switch over.
A critical one, it comes up all the time.
The good old durability question.
Yeah, and quite right, Jonathan. I think that's probably the key thing, because all the model, and look, to be honest, I'm not a great fan of durability models because they've got so many variables that are quite interlinked and also questionable in some areas. So I think we've got to get back to the basics of looking at, are these mixes able to produce the same sort of data points or better data points than the existing mixes from a durability point of view, both from chlorides and carbonation. The other thing, and Estella and I have a lot of discussions around carbonation, because, and I would recommend, and I might put it in, well, we could probably send it out, there's some really good papers around the fact that carbonation itself is not a carbonation reaching rebar is not the major problem that is sometimes indicated. And I know a lot of the durability design, you sort of want to have a mix that doesn't allow carbonation to reach the level of rebar in the design life, and I see that as too conservative. There's a lot of evidence to show that once you get over 20-25 mil of cover, you've got to have some other things going on with your deterioration mechanisms to promote corrosion rates at all, and or corrosion rates that are anything more than very low, and therefore superficial in terms of not allowing the elements to reach their 100-year design life, because it comes back to the amount of the resistivity, permeability of the concrete. So that's the way we're going to be looking at it, is to do benchmarking against mixes that have been around for a while that we know perform in certain environments and matching those. And I think that's the right way to go, because otherwise we'll tie ourselves in knot and never come up with an answer that satisfies everyone. So that's the approach we're taking. And as I said, we've got data from high SEM mixes from 30, 40 years, and we've used high SEM mixes in, as I said, in aggressive environments, and carbonation isn't the concern that some people are making it out to be, or we just need to be a little bit more rigorous in our durability design, not to just factor in or try and stop the carbonation front from reaching, but ensure the quality of cover and the thickness of cover. And most infrastructure projects that we're building, 45 mil is the minimum cover, and that's plenty of evidence to say that's plenty enough, even if it's carbonated, to still get your 100-year design life. So that's how we're going. So hope that satisfies.
Miles, I might just, noting everyone can't see all the questions, I might just read out Jonathan's question so everyone knows what you were answering there. No, all good. So the question from Jonathan was, in durability service life design, chloride and carbonation modelling, how have you overcome the lack of published guidance performance data around calcined clay concrete, like typical references such as FIB bulletins, etc., in performing service life calculations in the design stage? So, yeah, that was the question itself. Estella, did you want to add anything?
No, there are 2 more questions about durability, related to durability, and I will say that yes, there is lots of additional durability being done by Deakin University, Raquel at Melbourne Uni. There is one specific question here on creep. Raquel has been doing some creep, long-term creep testing, and the results are very very surprising, and gets us, part of that excitement as well is that long-term performance creep and durability, with the possibility of getting this mix, because these clays are so reactive, to get these materials that have very low permeability, and therefore durability is going to be way improved because of the permeability performance.
Thanks, Estella. I might move on to the next question. So Steve Howe, nice to see you online, involved in the early days of these discussions. So Steve's asking whether there's any trials planned with applications such as strip footings, topping slabs for composite structures, such as super T bridges. Miles or Estella, do you want to talk a little around maybe the structural testing work you've been doing?
Yep. In terms of very high SCM mixes and low GP, those have already been done. So there are bridge decks that have been cast in Victoria with a 75% SCM mix. And yes, we will want to substitute in clay for those mixes and do that and use them as well. So that will happen. You're quite right. The replacing slag and fly ash, as I said, we're trying to, there is some hope, because the concrete suppliers and cement producers in particular, Stephen, because there was a follow-up on that with the high energy demands to make GP cement and the just looking to replace GP cement. We don't see that as being feasible, except in the terms that just geopolymer is starting to, is also being trialed and reused or used again in the market in Victoria, and we're keen to promote that as well as the clay to give us both. But we're seeing it really is, as I said at the start, we're trying to get the GP as low as possible over the next, and then focus on that slower evolution of can we get rid of GP cement altogether, and some of the cement manufacturers are starting to blend to make the clinker clay with limestone, so they're reducing the amount of CO2 that gets emitted when clinker is produced, and they're obviously trying to decarbonise the heat energy inputs. So those are happening in the background, but we don't expect those to sort of kick in till, that will help us get to net zero, but we're trying to get to the 35% reduction as quickly as possible. So that's why we're focusing on just getting it as low as possible. And to give people, on the call who probably, we're trying to get it under the 100 GWP, the equivalent or greenhouse, the GWP amount. When you look at what we're typically seeing, three around the 300 is pretty good. Some low carbon mixes are down below 250. which is good. But if we can get everything below the 100 mark for equivalent CO2, then that will get us a long way towards the towards net zero. And then we know the last 20 years, sort of from 2030 to 2050, is going to be very hard, but the expectation is that that will be solved by the cement manufacturers.
Yeah. Thanks, Miles. Just moving on to a few more of the questions in the chat. So Mehdi had a question just around the structural application and whether that's going to be, will that be for precast as well, or is that just for in situ concrete?
Yes, both. Yeah,
both.
Yeah,
okay.
We've got to get everything. Yeah, down for that. Yeah.
Super. And I might come back to the other question. There's a couple here just around the kind of supply chain side. So one here from Anonymous. Can you share around the progress on scalability of calcined clay? I understand that in Victoria, the clay is being calcined by Calix in Bacchus Marsh at a small industrial scale. Can the whole industry, especially small independent suppliers, access calcined clay soon?
Yeah, well, the simple answer, well, the Victorian supplier is confident about being able to do 30,000 tonnes, which when you look at what, if you're replacing 20, 25%, even 30% of the cementitious content, that goes quite a long way. That's a lot of cubic meters of concrete you can. So yes, all the three, we call them four majors, have access to it and are using it. And also do there are some secondary users, like we mentioned, DIFAs. I think there's a couple of others that have got access to it. So the good thing is it's there and available, and the supply and the person and the company supplying it, Green 360, they just want to start to see certainty in terms of if they step up, they've got plans to install a much larger calciner on that clay plant at Pitong, and being able to kick it up to 250,000 a year and even more if the demand's there. So it's purely now, is there going to be the generation of the demand that will allow them to invest in that capital expansion of their plant? That's as simple as that. And that's one of the things that should call out Suburban Connect and SRLA, who they're pushing just to use it, not that they haven't stepped it up into structural concrete. They're just trying to get a throughput to at least give some to encourage that demand and to give Green 360 and AusPos in Queensland the ability to start looking to the future and what they need to do to expand the supply.
And just to touch on that, Miles, in terms of the sort of supply in Victoria, there is plenty of clay. I mean, we all went out to see the quarry, and it's there's massive amounts that they're already accessing for medical purposes and things. It's super good quality. I was blown away at the quality just sitting there in the ground.
Sorry, I'll just add to that. I think that's, to some extent, we're fortunate that the two first sort of commercial suppliers are a really good quality, and that allows us to ensure that when we can show that clays of that quality can be put into concrete mixes, but outperform even GP cement. They're more reactive than GP cement, and they've got better durability properties than GP cement. So that's great because we can prove that. But the other thing we've done is, as Stella pointed out, we've also done trials with much lower quality clays, even in fact some that we just dug up on a site, and M80, part of the NEL project. And that was just basic clay soil. Anyone can go in the back of their garden, get similar soil, calcined it, and was still able to partially replace cement. So we've done almost the two ends. We've got the top end, and now we've also done the bottom end, which should give everyone the confidence that it's a robust, for want of a better word, SEM. And it's just a question then of finding out what levels you use it to the extent that Green 360 might have to actually to make it commercially viable for domestic and commercial, residential use, might have to blend it with other products to take the sting out of it, to some, for want of a better phrase. So yeah, so that's why it's so exciting. We've got a great clay that we know will perform where we want it to at the top end. We've shown that the bottom end is equally as good. So it's going to be an interesting to see how the total industry develops over the next 20 years.
Thanks, Miles. Maybe one more sort of question just from my side around sort of standards and approval pathways. It'd be good just to maybe give everyone on the call a little bit of an update. So Vic Road 610 is currently going through updates, which will allow for calcined clay. But there's also some work underway around sort of approval pathways, which Miles or Estella let you talk to a little bit more.
Before Myers maybe can do a bit more, but I would just, if AS 1379 has recently been republished, let's say, and now it allows for calcined clay geopolymers, so there is allowances there for the supply of concrete to take these materials on board, and maybe Myers can add a bit more on these materials or low carbon concrete approval with Vic Roads or DTP.
Yeah, I think it's important. Holly, some people would be aware we've got sort of a VEDA, SRLA low carbon concrete working group that's been ad hoc in the past, but very effective at sharing information, and now it's been more formalized, and Holly's actually chair of that, and it involves DDP now, VEDA Rail, VEDA Roads. So that's great. And so there's actually a commitment now at the higher levels within DDP and VEDA to make this happen, and to work out what needs to happen, not on all those three fronts, but mainly in the specifications and standards to progress this with as much risk control as possible, but improving the ability for suppliers to bring these products and get them up and running as quickly as possible. So we're trying to tweak, and I know in the past, or some people see the Victorian mixed registration program as restrictive, but the beauty of it is it actually means if we can just tweak that and make it into something that can actually control these new mixes, allow control, risk control within the new mixes, but give a lower level of approval, which we're sort of talking about a conditional approval restricted, just so you don't have to do all the testing and get it, creep and everything else, but identify, get it into the market, use it where it's in under control conditions, have the right people overseeing it, but at least have some of that product flowing in and getting underway. That's the idea that we're sort of discussing in that forum now, to use our, for want of a better word, the specification, by pulling back the specification from being very prescriptive to more performance-based. The mixed certification program gives DDP the ability to still have that control over what gets approved. So I think that's something that we're very keen to see happen, because we think it will unlock and make it easier for people to bring through mixes that are going to change the thing, but get it up and running quicker than it has been in the past.
And I'll just quickly add that there is that understanding that having visibility, a better visibility on the mixes that are approved, so projects don't need to dig that information, and which becomes another hurdle to get these things implemented. So having a type of register with all mixes that are approved, that would bring some benefits as well. So there is some work being done in that space as well.
Yeah, thanks, Estella. You read my mind. So yeah, VEDA Rail have done some great work on having a sort of register of those low carbon mixes, and as part of that working group that Miles talked about there, which is actually chaired by DTP. So it's very much their group. But yeah, we're looking at how we can share some of that information publicly, so that people all have access to see what low carbon mixes are registered. There's probably time for one more question, and then we might wrap up, and any questions we haven't answered, I know there's a few more technical ones there we'll respond to. I might go for, just on the topic of kind of DTP and mixes, there's a question here from Anonymous around AS 1379 now allows for calcined clay, as Stella mentioned. Do you think DTP will allow calcined clay into the Vic Road mixes at some point, and what's the pathway and progress regarding that registration? So I think we've talked a little bit to that with the 610 update, but I don't know if there's any more to add, noting we're not DTP, so we, yeah.
I think I'm always a bit, hopefully not overconfident, but I'm pretty confident it will, because I think everyone understands that you know, as Stella says, there's been a lot of work done overseas for 20 years in this space, so I think there's not going to be a problem of getting calcined clay as long as it keeps performing. To give people ideas, we're sort of seeing 40 MPa mixes which comply with Vic Roads in current 610, but they hit 80 MPa at 28 days. So it tells you that this material is absolutely not a step backwards, it's actually a step up in terms of quality. So there's not going to be a problem, I don't think, for DTP to accept the use of calcined clay. It's more a question of, are we going to get the full benefit of it by starting to look at reduction of total cementitious content and getting a carbon reduction that way, as well as so to take advantage of this very good quality material. And I just saw the other one, which is anonymous, is, you know, is there supply here and is it likely to be imported? Definitely not going to be importing any calcined clay into Australia. If anything, I think some of these clays might actually go exported if once the industry gets going and established. So I think that's another thing, you know, Victoria and Queensland, with their, you know, but particularly in Victoria where we've got clay everywhere, and really good basaltic volcanic based clays, could well be a new industry that really, you know, cement industry that could be really exciting. But we won't get ahead of ourselves. Let's get the first problem solved and get it up and going here. But,
thanks, Miles. I might wrap things up, but I do want a little blue sky thinking last question for you both. 12 months from now, where do you want us to be with calcined clay? Yeah, aim for the stars.
Well, I'd like to see a Super T or a U trough, you know, pre-stressed member, poured and tested and shown that it's doesn't have any different structural performance and load capacity than what we're putting up now. So but just being able to tick that box would be great, and that's what we're trying to do. But and maybe an export into, you know, I think it'd be great if suddenly, you know, people realize that Australia's got some high quality clays and start coming to us wanting it. I understand the US is importing clays from Brazil, and there's no reason why that industry couldn't kick up to that level. That'd be great too.
Thanks, Miles. Stella?
I think that's it. It's a teamwork. Not only me and Myers, but everyone, as Maya said in the beginning, is part, you know, it's everyone's, it's a combined effort. And we have seen, if it was not a combined effort, it wouldn't have been this fast. And I'm confident we can get there.
Super. Okay, I would like to thank you both for your time today. Yeah, it's been a really fantastic discussion. I feel like we could talk about clay all afternoon. Yeah, the recording will go up on our YouTube channel. If you've got any further questions or any questions that we didn't answer, please do follow us up. Emails are there, and I will direct things over to Miles and Estella if we need. But yeah, thank you all for your time, and have a great rest of your Friday and weekend ahead. Thank you.
Thanks, Polly. Thanks, Lauren. Thanks, Ecologiq. Thank you.
Bye.